Determine the required length of the cord AC so that the lamp of 8 kg can be suspended in the position shown in the figure. The undeformed length of the spring AB is given as 0.4 meter and the spring stiffness is given as 300 Newton per meter. So in this problem, indirectly the problem is given as the equilibrium condition. So the lamp is suspended in the position. So it can be mean that the system is assumed to be in equilibrium. So we know the conditions for equilibrium: summation f of x equal to 0 and summation f of y equal to 0. So reading the given question, want to write the given data. So the mass of the lamp is given here is 8 kg. So convert the 8 kg into Newton, and length of the spring AB in the undeformed condition, that is the initial condition, AB is given as 0.4 meter and stiffness of the spring K is given as 300 Newton per meter, and the distance between horizontal distance between B and C is given as 2 meters. So here we want to find out the length of the cord AC. So the first step is to draw the free body diagram. So given space diagram is converted into free body diagram. So at the point A, the weight will be acting downwards 7.5 newtons, and the string AC is taken as the tension in the string AB acting along the positive x-axis, and the tension in the string AC is taken as TAC, that is directing upwards at an angle of theta with respect to the x-axis. So now the next step is to resolve the force. Create the table with force as one column, angle with respect to x-axis in the next column, followed by horizontal component and vertical component Fx and Fy. So the units are mentioned as Newton, theta and newtons. So here three forces are acting: TAB, TAC and W. So TAB and TAC are unknown. So I am putting TAB and TAC, and the weight of the lamp is taken as 7.48 newtons. So this TAB is 0 degree with respect to x-axis and TAC is 30 degree with respect to x-axis, and the weight is acting vertical, that is 90 degree with respect to x-axis. So we want to find out the horizontal component Fx. So Fx is usually taken in the cos angle and vertical component is taken as the sine of the angle. So here TAB cos 0 and the tables are created. Here TAC cos theta. So here the tension in the force string AC is directed in the negative direction of the x-axis. So here we are putting the negative sign and all other things remain same. Here after creating this table, we want to find out the summation f of x, summing up all the horizontal component to get the summation f of x, and summing up all the vertical components will be getting summation f of y. So here f of x equal to TAB cos 0 degree minus TAC cos 30 plus 78.48 cos 90, and summation f of y equals TAB sin 0 plus TAC sin 30 minus 78.48 sin 90. So here the lamp is held at a position which is in equilibrium. So we know the conditions for equilibrium: summation f of x equal to 0 and summation f of y equal to 0. We already find out summation f of x and summation f of y, and equating the equations to 0, we will be getting tension in AB minus 0.866 TAC equal to 0 and 0.5 TAC minus 78.48 equal to 0. Here we'll be getting two equations. On solving these two equations, we'll be getting the tension AC as 156.96 Newton and tension in AB as 135.92 Newton. So here one part of the question is over. Now coming to the, here you have the spring. So we want to calculate how much the deformation has happened when the load is applied. So here the magnitude, the spring magnitude, have the force F acting in the vertical direction. So initial length of the spring is taken as L0. After the application of force, the length of the spring changes to L. So that is, there will be an increase in the length of the spring if the tensile load is applied. Suppose if there is a compressive load, there will be a negative change in direction. So the undeformed length is taken as L0, and after the application of force L, F, the length of the spring changes to L. So here the total length will be L. So there will be change in length is equal to L minus L naught. So this change in length is due to the stiffness of the spring. If stiffness is more, the deflection, the length will be less. So the magnitude of the force here can be calculated as F is nothing but the product of stiffness and the change in length. So here we know change in length as L minus L naught. So I can replace this equation, F equation, as F equals K into L minus L naught. Then coming to the problem, here already we have discussed how to find out the tension in AB and tension in AC. So tension in AB is 135.92 Newton and tension in AC is 156.96 Newton. So now the stretch in the spring AB is equal to the force. So the tension in the AB is equal to 135.92. That is nothing but K of AB into S of AB. So already the K of AB is given as 300 Newton per meter and S of AB only we want to find out. So using this previous equation, we can find out S of AB as 0.453 meters. So the stretched length is length of AB is equal to the final length L length of AB plus the stretched length of AB. So L of AB is equal to 0.4 meter plus 0.453 meter. So you will be getting length of AB as 0.853 meter. The horizontal distance from B to C we can find out using AC cos theta. So L of AC cos theta plus 0.853 meters is equal to, we will be getting length of AC as 1.32 meters. So the answers are, the tension in the string AB is 156.96 Newton and tension in AB is 135.92 Newton and the length of the cord AC is 1.324 Newton. Thank you.